Hello here. We have done introduction to organic chemistry. So now let us discuss properties of alkanes. Now physical properties of alkanes. In my previous lecture I have told you about alkanes. These are hydrocarbons and all the carbons they have single bond between them. So their physical properties, as they are covalent compounds, so they have low melting points and boiling points, as we have studied in our previous chapters, where I have told you that covalent compounds, they have simpler molecular formulas and they have low melting point and boiling points. On the right corner I have drawn a graphical representation of the boiling points, and with the increasing number of carbon atoms. Graph is not drawn to scale, just to show you that as the number of carbon atom increase, their boiling point also increases. They are insoluble in water and they are soluble in organic solvents. They are inflammable, which is the very common property and specific property for alkanes, hydrocarbons, that when they are ignited, they start burning. That's why they are called fuels. Properties which depend upon their molecular sizes. Number 1, melting points and boiling points increases as molecular size increases because of increased intermolecular attractions. Number 2, they become more viscous as their mass increases, flow less easily. As the size of molecules increase down the series, they change from gases to liquids with increasing viscosity. You must have seen the oils, especially the oil which is grease and which is the oil which is added in our car engines. Number 3, they become less flammable with the increase of size because of increased number of carbon atoms. They produce smokier flames due to the incomplete combustion. Now, as the carbon atoms increase in a molecule, it needs more and more oxygen, whereas in air, oxygen is 20%, so it becomes a limiting factor. And the smoke which comes out from the flame, it is actually the unburnt carbon. Now we study chemical properties of alkanes. Generally, alkanes are unreactive because of strong covalent bonds between carbon atoms which are difficult to break. However, alkanes undergo some reactions in specific conditions. Well, alkanes are also known as paraffins, that is low affinity, which means they do not react. Number 1 chemical property of alkane is combustion. Well, I have drawn a flame in front of it, which shows that when ignited by a spark or flame, they readily burn in excess air, which means oxygen, to produce carbon dioxide, water vapor, and heat. And that is why you see whenever the fuels are burnt, stoves are burnt, gases in our heaters are burnt, they all become hot and they give you a lot of heat. So while alkane, I have written a word equation. Alkane plus oxygen forms carbon dioxide plus water and heat. Now let's take the example of first hydrocarbon, that is methane, plus oxygen, carbon dioxide, water. I have written the formula CH4 state symbol gas, oxygen state symbol gas forms carbon dioxide gas, water gas. Water will be in the form of vapors because of lot of heat produced. These reactions are highly exothermic. Now, exothermic reactions are those reactions which produce heat. That is why they are used as fuels. Methane used as cooking gas, kerosene oil, petroleum fractions, diesel, petrol, these all have alkanes. Now, there are some example of combustions. I have written the equation. Ethane C2H6, I have given you the formula. In the presence of oxygen, carbon dioxide water is formed. Propane, in the presence of oxygen, carbon dioxide and water are formed. And remember, heat is always produced. You can see the balancing of the chemical equations. When I am going to do the chemical equations, I will teach you balancing over there. The only thing which I want to mention here is that is number of atoms on the left side should be equal to the number of atoms on the right side. So we write some coefficients and try to balance these equations. Methane is odorless, which means it does not have any smell. Colorless, as it is highly inflammable and is used in cooking. So foul smelling chemical is added to the gas so that its leakage is detected in the houses. And these foul smelling chemicals actually are compounds of sulfur. Now, the reaction which occurs, which alkanes undergo, that is substitution reaction. Condition needed is sunlight or UV light. Alkanes react with halogens, chlorine or bromine. Halogens are actually elements of group 7. Fluorine, chlorine, bromine, iodine and acetylene. In the presence of sunlight or UV light to undergo substitution reactions. Reaction with fluorine is explosive, whereas with iodine is very slow, so we say that it does not occur. In this reaction, a hydrogen atom is replaced by a chlorine atom to form chloromethane. One by one, hydrogens are replaced if the reaction is allowed to carry on. Now I have given the reactions in the form of equations. Methane plus chlorine, UV light, it forms chloromethane plus hydrogen chloride, as one hydrogen comes from chlorine and one chlorine comes from the chlorine gas, so they both combine, and one chlorine atom is added into methane instead of that hydrogen replaced. That is why it is called substitution reaction. I have given the written the reaction. Methane plus chlorine, UV light, chloromethane plus hydrogen chloride gas. Now chloromethane is also named as methyl chloride. Now I have said that all the hydrogens can be replaced one by one if the reaction keeps on going. Now this I have explained in these reactions. You can see methane. First of all, one hydrogen is replaced with chlorine, which I have written in blue color. Then another hydrogen is replaced by another chlorine. So the first product form is chloromethane and the second product form is dichloromethane. Di means two. So you see the two chlorines have replaced two hydrogens. Then dichloromethane changes to trichloromethane and the third hydrogen is also replaced by chlorine. Then the last hydrogen is again replaced by chlorine. So all the hydrogens are replaced by 4 chlorine atoms. So this makes tetrachloromethane. Now complete substitution produces 4 products. Number 1, chloromethane. Number 2, dichloromethane. Number 3, trichloromethane, commonly known as chloroform, used as anesthetic. Number 4, tetrachloromethane. It's an organic solvent. It is used in dry cleaning. It is volatile, so it evaporates, as it is good in dissolving dirt and grease. Now these were the common compounds which are formed. Now remember, trichloromethane is chloroform. You must have seen in movies, in television, that the burglars, they come and they have a handkerchief in their hand, and they put that handkerchief on somebody's nose, and the person goes unconscious. So trichloromethane is used as a chloroform. Now there is a question. The substances X, Y, Z are alkanes. Identify them. Now you can see X plus chlorine forms chloromethane, Y plus chlorine forms 2-methyl chloropropane, and Z plus chlorine forms 2-chlorobutane. So here we have to look at the position of the chlorine, and for our answer we are just going to replace chlorine with H and we'll get the product. And we'll get the reagent X. So first, replacing chlorine by hydrogen, it comes out to be ethane. Second, replacing chlorine by hydrogen, it comes out to be 2-methyl propane. And in the third one, replacing hydrogen, it changes to butane. Now just to make the naming of the compounds easy, I have written them in a dotted form. That is, in first chloroethane, you can see that ethane makes 2 carbon atom makes ethane, and there is 1 chlorine. In the second one, why we say 2-methyl chloropropane? Because there is one rule, that is, if there is a functional group attached to a chain, we are going to number it the least. So I am going to number carbon 1, which is attached with chlorine, then 2, and then 3. So if we closely see, we see that methyl group is attached to carbon 2. So we are going to mention the name or number for the methyl. So it is 2-methyl chloropropane. There is no need to write 1 chloropropane because 1 is not mentioned. Then the third one, you can see that I have again numbered the chain and have tried to number the carbon to which chlorine is attached the least number. So it is number 2 carbon to which chlorine is attached if I start from the left side. If I start from the right side, it makes 3, which will be wrong. So chlorine is linked with carbon 2, therefore it is 2-chlorobutane because the chain of the carbon has 4 carbons. I have written here, carbon atom with a functional group is always given the lesser number. Above mentioned substitution reactions can be done with bromine. Just write bromine instead of chlorine. So first I have written methane plus bromine, it becomes bromomethane, and so on and so forth. There is a simple question for you people. A, C6H14, B, C16H34. On ignition, which will give out more smoke? Now remember, larger number of carbon atoms are difficult to burn, so they need more oxygen. Because they need more oxygen, that's why B will be our answer. Because it has 16 carbons, it will need more oxygen, so will burn incompletely. Another name for this incomplete burning is known as incomplete combustion, which I am going to discuss in our next lecture. I hope you have understood my lecture. So please give me comments